k plus 1. And that is essentially the same thing. If I give it k, 5, well, my function, 5, I get 6. And if I give it 6, I get 7, and so on and so forth. This syntax, you just give it a variable name, my function. You're giving it an argument list, right? And then you're giving it the result. And this is just a shorthand for this up here, which we can't see because my screen cut it off, but I'll pop it back up. Those two things are the same. So this here is declaring a function x, which takes an a, and it returns an a plus 1. This is declaring a function, my function, which takes a k, and it returns k plus 1. That's just the fat arrow syntax, and the one below it is the function syntax. You can use whichever one you like. They are mostly identical. Okay, quick question. What 3-letter word do we use to declare a variable in JavaScript?
Let.
Let.
Let, yeah.
Let, right? Use let to declare a variable in JavaScript. Does anyone remember the 3-letter word you can use that's not let that you can use to declare a variable, but that we will not use?
Var.
There we go. If you see var, you're doing something wrong. We don't use var, right? Var is old. There's nothing better about it. Okay, if you have a variable, let's say the same way you have declared it with let, but it never changes in the program. Const, right? So you have a method of declaring a variable that you will never change, and that method is const. So we can say const hello equals 7, and now you know that as long as hello is there, you can't change it. If you say hello equals hello plus 1, you get an error. Assignment to a constant variable. What's up, Peter? Welcome back, my friend.
Thank you so. Thank you so. Didn't mean to be late.
No, it's all good. So we have a method of declaring a variable with let. We have a method of saying that variable is constant with const. And let's take a look here. Oh yeah, let's talk about loops. What kind of loops do we have? We went over this in the last class too. Anyone remember? For, while, do while. We got a do while. What else do we have? For, while, do while.
For each.
Okay, we're going to get to that one today.
We went over that one though, I thought.
We're going to get to that one today. So our big loops are for, while, and do while. What's the difference between a while and a do while?
Do while will run it once first before loop.
It'll run it at least once. So a for statement, rather a while statement has a condition inside of it, and that condition gets checked. If the condition fails, you don't run it at all. A do while also has a condition, but it checks the condition after it runs it the first time. Right? All right, we went through scope. What determines scope in JavaScript? There's an easy indicator. And I said that we can get, like this guy went into a lot of crap about scope, and I tried to keep it very simple. What determines scope in JavaScript? Does anyone remember the trick?
Curly braces.
Curly braces, it's that simple. As long as you're using let, you get sanity through and through. The curly braces determine the scope. Okay, what do you call it when a function calls itself? Recursion, right? What do you call it if you have access to the function scope outside of the function? And this is a way that I don't know if I worded it before.
Closure?
There we go, a closure. A closure, right? So we went over this last time and we kind of said that normally when I teach it, recursions are what really throw people off. But in this one, we had a little more difficulty with closures. Did anyone see that I had put a message on the Facebook page about a closure example, something people could play around with?
Oh yes.
You guys saw that? Okay, we're going to go over that in class, and I'm going to take a look at it. And we're going to deconstruct that, and I'll show you different things about it. All right, loops, code indentation, code control. went over this too. As a quick pointer, especially if you come from a different language. JavaScript only checks the names of the functions when you call it, remember? So if you provide to it different arguments or fewer arguments, it doesn't matter what the arguments are. That's only there for convenience. The function is getting called regardless. And closures. All right, let's take a look at the example that I gave on the Facebook, and then we're going to field any questions people have over that first lesson. Third lesson. Actually, I'm going to find it here. There we go. Okay. All right. Okay. All right. I don't know that I like that indentation style. We're going to look at it here instead. Who wants to take a crack at it? Who wants to try to explain what it does? Any volunteers?
I'll start. I've never seen it before, but so obviously there's a function named f with no arguments, no parameters. Let sets the counter to 0, initializes it. It returns nothing, looks like. Oh, it returns what's in the curly braces. Okay, so
it returns itself.
It keeps returning itself plus 1. It keeps counting up, and I'm not sure what happens after that.
It was great.
Yes, I see something a little different. So yes, you did. It's returning another function which does a counter plus 1, and then returns another function which is just the result of that plus 1 that you added.
That's right. Okay. So let's look at this, and let's imagine in our head, because one of the things I wanted you just to get out of this is kind of like, when you see code like that, it's always an option to go right to the node or to the console and to say, let me play around with it and see how it runs. But it's definitely a better mental exercise to kind of prepare yourself for it and think about it and see.
Too much Perl.
What's up?
If somebody's done too much Perl.
This is?
Yes.
This is actually very not Perlish. This is much more Lispish.
What's the purpose of the functions?
We're gonna go through that.
Why should you go that roundabout way?
We're gonna go through that. And in fact, this is not necessarily a great function, right? The point of this function is because I want to get people into thinking like an interpreter, like JavaScript would. So you can try to figure out what you're expecting here from this code. You can make sense out of it without running it. So we know that we have a function f, and if we call that function, we're going to get a function back, right? Let's look at that. Let's say we have a variable inside of it. There's only one variable inside of it. What's it called? Counter. And that variable is scoped where? What can see that variable?
All inside the function.
All inside of it, right? So everything inside of that function f can see the variable counter. Now if I call f and I try to access counter, after I call f, what do I get?
An error.
Get an error, right? I get an error because it's not in scope. It's only in scope inside that function. Now let's say that I call f, and we know I'm going to get a function back, right? What happens if I call the function back? No. If I call f, I'm going to get a function back, right? What if I call that function? What happens?
Another function back.
Nothing, you have to know.
Okay, let's look at it.
You have to put it
Let's look at it. We have a function here. This is what we're going to get back. Is this guy inside of it? If I call this guy inside of it, what's going to happen? Counter is going to get incremented, right? You guys aren't saying that. That's going to happen. So when I call the function I get back from f, right? That's, if you have a function that you're returning and all it ever does is return a variable, you're literally just wasting your time. Just return the variable, right? So we're going to take it. We've already taken it. We've dropped it into node, right? Of course, the screen is ugly because it's got a lot of crap. Make it a little bit smaller. We have it right here. Now we have an f. We're going to call f, And we're not going to see anything except the function get returned. I'll show you. F. Okay, now here's your extra credit question. What is it going to look like when I type this in, when I hit enter?
It's going to print out the whole thing.
You have a function and just say function.
It's going to just say function, right? It's going to just say function because Node will not textify the function. Now, some things may, like development tools if you're running them in Chrome. But Chrome is just going to say function, right? And that's it telling you that that's code. I don't know how to show that code because it speaks computer CPU nonsense, and I don't. I'm JavaScript, and I'm stupid. But that's the way it tells you that. So from this point on, if I want to call that function, what do?
You put a number to it? The name?
He's got it in the back. What was your name?
Chris.
Chris has got it in the back.
So you invoke it again.
You invoke it again. How do you invoke a function in JavaScript?
Open and close parentheses.
Open and close parentheses. So I go like this, right? Now, Chris, what am I going to get if I do that?
Now you're going to get 0.
No.
Function.
The
That's
value
right.
of function?
That's what I want you guys to see. It's not about utility. It's about understanding this kind of stuff.
Right.
What am I going to get back? Someone else.
Function.
Function.
Return a function.
It's going to get this. So this
Very
is
last
some
one.
inception stuff, right? Very simple looking. Now I get another function back, right? Now what am I going to do here? Come on in, ladies. We're showing this horrible piece of code. Backstory, we've kind of like reviewed a little bit about what we have to do. What we've done in the past, 3 weeks? And I had this piece of code that didn't make all that much sense. I put it on the Facebook, and we're now trying to go through it, and I'm taking people through it, and we're looking at how ridiculous it is. So we've called the first function, right? This, and it's returning this guy. This guy represents this thing in the middle, right here, right? And I said, what happens if I call that? And we did, right? And that was a trick question, because you wanted the variable back, which would make sense, but you're not getting it. You're getting this, which is another function, right? Now, how do I get that one? Another one, right? Another open and close parentheses. Now what's going to happen if I do this? What am I going to get back?
1.
Nope, not yet.
You say not yet. You're poisoned, man. I've ruined you. You just can't believe that the game is over. I'm going to get 3. Okay, that's crazy. I don't know where you got that from. Anyone else? No, I'm joking. But
You're just going to get 1.
we're going to get 1.
Yes, you're going to get 1
Maybe 2, huh? You're going to get 1, right? You're setting the variable equal to 0 with the first call. You're incrementing it in the second call. You're returning it in the third call. This is a closure. It's needlessly complex. And one of the things you can do here is, we're teaching JavaScript. JavaScript is a very simple language. It's very simple because of what they call imperative. You're literally telling the computer, do this, do that, do this, do that. Not every language is like this. There's a whole other class of languages called functional languages. They're a lot more fun. But if you use something like Lisp or Haskell, you would see this quite frequently, and you can actually model whole programs just using closures, right? So you don't have objects in some languages. In JavaScript you do, and we're going to get to it. But there's a lot of stuff you can do with this, and it does get complex, and it's kind of neat to be able to look at it, figure it out without running it and cheating. All right, we have questions on it. Chris?
So could you assign that variable and run it that way?
Let's do that. Let's actually take a look at that, right? So this is absolutely insanity. I'll tell you why it's insanity. It's insanity because, A, this is a horrible API. You don't want to ever give this to a user. But also because after you use that, you have this crap, which doesn't make any sense. So what we're going to do is we're going to look at it in more practical aspect. And we're going to say, OK, let's give this a variable name. And then let's give the thing it returns a variable name. And then let's give this thing a variable name, right? And we're going to look at it each step of the way and actually look at what variable names can do for clarity, right? And here's the kicker. We're not actually going to look at what the variables return, even though I think this might tell us anyway. So here, the first one does what? Let's look at what the first one is doing. The first one is setting counter equals to 0, right? Now here, when you're setting something equal to 0, because this is essentially the preparatory work for your process, in programming, we typically call it, does anyone know?
Initialization.
Aha, we got 2 people that got it right. Init, right? Initialization. You'll see this everywhere with computers. Your first task when your computer boots, init. This, you can also call it init. It's just whatever you're doing to set up your work. Come on in. By the way, just so everyone knows too, if you interrupt this class because you come late, it doesn't actually matter because it's not a real class. It's just something we're doing to get people into programming. So I want everyone to feel like that's totally cool. Okay, so we're going to look at it. We have the first one. We're going to call it init because that makes sense. Let init equals f, right? Boom. Okay, now we're not actually going to look at what init is equal to. But we know what init is equal to because init is equal to this, right? So I'm saying let init equals f, and I know f is equal to a function, so you know that that's what that's equal to. Now, what happens here if I call this initialized stuff, right? Now I have this, right? If I call it, what's happening? What is this?
First inside function or the second function?
No, I like what do we say?
Increment.
Increment, right? We're incrementing. So we have a counter that's getting initialized, right? And it's returning a function. And if I call that function, it's doing what? Incrementing. It's that simple, guys. It's incrementing. It's also going to return something else, but it's incrementing. So what we're going to do here is we're going to say let increment equals init like that, right? Okay. Now I have one more function here. And what does this equal? This is your variable, right?
Yeah.
So what are we returning? We're returning a counter?
Yes.
What, and we can usually just say get counter. That's how we typically write that, right? So we can say here, let get counter equals increment. Now if I say get counter, you're getting your 1. Now let's say we have increment, and then I do increment like that. I'm still getting a 1, right? And that's kind of interesting. So I'm calling increment twice, but it's not actually changing the variable of the counter. Does anyone know why that is?
The init sets to 0 every time?
We're not calling it
You need to
though.
assign a number?
We're getting a different variable because when we look at that, we go what?
Two different instances.
2 different instances, right? 2 different instances. So we're saying get counter equals increment right up here, but it's equal to 1 increment. These increments operating, it's going to increment counter. Today we're not a problem. Today we're gonna go over that. That's called mutability. We're going to mutate counter. Every time we call this function, we get back, right? So we call f, it sets counter to 0. We get a function back, which gives us the ability to increment counter, right? And this is why I wanted to go through it. I want to go through it not because this is a useful function, because it's not, but because this is something that is not very easy to understand, and if you can, you understand closures. Okay, now, we call this function, it increments counter. What is it returning? Another function, right? And what does that function do? If I call it?
It returns counter.
Returns counter. Is it going to be able to return counter?
Yes.
It is, because it's closing over counter. So we call this function, counter gets set to 0. It returns a function. We call that function, counter gets set to 1, and it returns a function. We call that function, and we get the result of counter. And it's only then that you get the result of counter. You don't know what counter is until you call that third one. You have no access to it. That's the point of a closure. We're seeing here that counter actually is getting, it's becoming private, right? You only get access to it if you follow that control flow that it's given. And it's not necessarily the most logical way to do it. There's a lot of good critiques about it. Let's say that I take this right here, and rather than returning a function that returns counter, I literally just say return counter. Did anyone see this? Did anyone get what this whole thing did? And then you saw this and you're like, what the hell? What's the point of that, right? So there is no point of that. That's the answer. A lot of people said this doesn't make sense to me. The whole thing doesn't make sense to me. The whole thing makes sense, right? But if it makes sense in a weird way. It's not necessarily the best way to do it, but that last part is indefensible. If you see that last part in production code, you've got a big problem. Let's just look at it here. Go back up to that function, and we have this thing here, and I'm returning that as increment. And then I call on it get counter. If I call this multiple times though, right? And I set that to a different variable each time, I'm getting a different copy. That's just part of scoping. With closures, you can access the same variable, but you don't always do that, right? So you kind of got to like look at that.
Can you do something about the board so you don't cover that one up?
Cover that.
It's
You
like a
mean do
pointer.
them both
When
separately?
you point to the board, you cover it up, so nobody on this side of the room can see what you're doing.
Ah.
It's the angle.
Okay, the angles are, okay.
Something like that.
I'll move around to a different one
You
then.
need 2 arms.
Yeah, I know, yeah. I need 2 arms and 2
Like
laser
a little
pointers.
stick, you know?
Right,
You need
so,
a handheld mouse.
so let's take it again, let's take a look at this.
You want a mouse?
I have a mouse right here,
Ah,
so I can use that.
there you go.
Okay. All right, let's take a look at this. So we have this function f, and if we call it, we're going to get that. We already went through it. That's that initialization step in it. Now, if I call it like that, I get 1, right? So the question is, if you wanted to call the counter and increment it twice, how would you do it? You would take this, and you would say, like that, and we can chain it. Let me give it a better name. That's a really bad name. Let increment equals init. Oh, we've already got one. Now I can call this twice, like that. And what I should be able to do is I should be able to say now, let get counter to equals increment to. And now I actually get the 5, right? So that if you, what I'm trying to say here is that you can name these variables, and when you name these variables, you don't work on a new copy every time. You work on the copy that you've named. I'm trying to think of a better way I can show that, because I see a lot of people that I'm losing on this. And this is the closure thing, right? Let's see here. All right. If I say f equals this, we're going to get the initialization, right?
You mean if you call it like that?
Call it like this, right? This is really... I'm trying to clear these variables so I don't have to keep renaming them 2 and 3 and 4.
What was the option to put in the color
Let's just restart it.
and the letters and all that stuff?
Okay. Now I have declared init equals f, and I've declared increment equals init. So now I have this function right here, right? This is the incremental function. If I call this function multiple times, I will increase the counter variable, the same counter variable, because it is the same function, right? If I assign this to something else, I'll get a different copy of that. So you can call init multiple times and get a whole different instance. If you call this right here, increment, multiple times, you'll be incrementing the counter variable here. So if I say here, increment, 1, increment, that should actually...
It's just reading what's on top.
Counter equals counter plus 1, return counter.
Because counter is 0.
Yeah, but where's this counter here should be 0, right? When we call it here, it shouldn't be 0. Let's see.
If you do that with init, it works. Init double parentheses. No idea why.
Yeah.
That's where
Somehow it's reading it from init.
It's what you're doing within the let
Yeah, that's it.
that determines the reference.
That's what's
I see what it's got going on here. JavaScript is getting funky. Okay, so yeah, the init piece that we're returning is the result of this whole thing. I don't think we're going to go over this. I think this is going to get too ugly and too confusing. The answer is that yes, Peter's right. It's in this let. This let is throwing this thing off, and I don't want to clarify on that one.
Yeah.
Let's just skip that.
So
The reality is that you have a problem here. When we thought we were calling this component on the inside, we were getting a different let each time for it.
Yeah.
And that's pretty ugly, but that is how Java works.
So what should we do instead?
You can do it just like that. I mean, we would just, like you said, you would put it in parentheses. So each time you call init like this, you're calling the incremental function underneath it. But if you say something like let k equals init like that, you're no longer calling the same function. You're calling a different copy of this function. So you have a copy here, right? What it's actually doing is you have a function here, and if you call it like this, you're calling the same function. If you call it like this, k equals init, you're calling a different copy of that function. And that's why it's getting screwy.
Can you relate mutability to closure, this, what was the S, in this context? Maybe that would help. Check it out a little bit.
Mutability to closure.
Right, do closures, not in closure with the J, but
In
apparently in
closure,
these
right.
other languages.
So
the
you have this
idea is that
variable.
you don't want,
Right.
it's an immutable.
You have this variable counter equals 0, and when you call it like this, init, and you put a parentheses, you're operating on the same copy of this incrementing function. And then when you do that, you're incrementing the counter. This is mutable. When you assign this function here to k, right, k equals init, then what you're doing is you're calling just this.
So which
You're
of
getting a
these,
different
so which
version.
of these is doing what closure?
Hold on.
You're not got that far yet, but.
This thing is encrypted.
It seems like if you forgo the let in your outer shell, it won't change in the last second. Because perhaps let is like making a deep copy of it or something.
Yeah, that's what I'm thinking. I don't want to do that. That's just gonna throw it. I'm afraid that that's gonna be like the rabbit hole there. Okay, so yeah, that's a lot of fun. We're not gonna go through it. The question here is, how do we copy this increment thing? And the answer is JavaScript is stupid, and I'll show this next time. That'll teach me to do simple examples inside of JavaScript. Okay, going through this where squirrel thing. In chapter 4, we're looking at data structures. So we have different data structures in JavaScript. A data structure is essentially a different method of storing data. And you have inside of JavaScript really two methods you'll see used a lot. Some languages have more. You have this notion of an array, and you have this notion of an object, right? Now, how many people here have any experience with Python or with Perl? So we have a bunch of people here with Python and Perl experience. Which one are you? Python. Python has something called a dictionary, right? In Python, a dictionary is different from an object, right? Here's the deal about Perl. In JavaScript, your object is your dictionary, right? So when you create an object, you are creating a dictionary in Python and vice versa. If you're from these worlds, it looks the same. And the reason for that is when you look at this, if anyone did this code, you have something like let object equals foo var. You can call this just like you would an actual JavaScript object, right? So for people that don't have any experience in programming languages, when you have a dictionary, you're associating a key and a value together, right? In JavaScript, this is called an object. And that's all it does, is it associates a key and a value together. Now, different languages do this differently, but in JavaScript, you can call that like you would any other method, right? We went over in chapter 3, look at it. JavaScript conflates all of these things together, and it just says all you have is an array and an object, right? So when you go through this, we see here that this structure right here is the simpler of the two. He's showing you this is how an array works, right? An array is positional. The key about the array is it's ordered, right? So if you have an array, you have element 0, element 1, element 2, so on and so forth. If you have an object, you have key, foo, key, bar, whatever you're having as your different keys, right? Most different problems you have can get mapped into one of these two things. Typically, if you have a deck of cards, right, you're going to map that as an array because you have a top of the deck and a bottom of the deck, right? That's how you would see this happen in the real world. If you have a queue, right, people in line or something of that sort, you may model that as an array. There's a lot of different problems that fit into one of two of those kind of situations, and based on that, you can grab either the array or the object in JavaScript. You get all the options. This is all of the things the array can do, right? Now, you may want to go through these and look at this, because this is part of being a JavaScript programmer, is having at least the common ones of these memorized. But in this case, the example he's using one called push, right? And push is very popular. So there's two that you're going to see in every language for arrays. Push. Anyone know what the other one is? Pop, right? So what do push and pop do? Push. Anyone? Where does it add? To the end. Pop. What does pop do? Where does it remove the element?
From the top of the stack.
From the top, right? So from the end and the top are the same thing. When people view arrays, right, it really depends on their model of viewing them. You can view an array as growing up vertically, or you can view an array as growing out, right? If you view it growing out, then wherever the out is for you, I guess it's, I view it, some people view it like that. Then on the other side of that, when you add a new item, when you pop, you're going to pop that item off, right? So that means that it's first in, last out, right? So the push pop notation, and he goes through that, is called philo. Is that entries? Entities is what we would call them. There's 3 different entities inside of that array. So if we
Which array? What?
this array here, this array journal is an array, and the array has, this is one entry, this is one entry, this is one entry. So when we iterate over this array, we're going to get 3 things back. And this is where he kind of pulls it all together. And by the way, that looks really horrible, but that's because there's a lot of stuff there. Okay, another quick point. Does anyone remember what happens when we evaluated a function? What did it return?
Function.
Just returned function, right? It just said function. Now when we evaluate this, we're getting all of this stuff, right? We can actually read this. So anytime you have an object or a variable, you have data, it can actually present to you data, even complex data. So what we're seeing here is we have a variable journal. It is an array with 3 different objects inside of it, and I'm printing it all out just by giving, to Node that name. It's able to do that. So what he's going to do is he's going to look at this journal. He's got this data. It's in the computer now, and we're going to look at making use out of it. So mutability, we went through that. Let's score. Okay, here we go. He creates a function here called addEntry, right? Now, if this is an array, right? Journal is an array, and we're calling journal.push. The end result is we're going to add a new element to that array, right? Rather than having 3 elements on that array, we're going to have 4, right? So if you had journal empty, you could actually call journal with an events and a squirrel status for each one of these, right? So let's take a look at it, and what he's doing is he's emptying it out. Journal equals this. And now what he's doing is he is adding it all with this thing called addEntry, just like that. So if we look at it, before we were having all of this stuff, we wrote it into the array with the objects. Now we're creating an empty array, and we have this function called addEntry, which takes an event and the squirrel status. And each time we call that, it's going to add to this journal array, right? And then we call it the first time, and we're adding to it events and squirrel. Work, touch tree, pizza, running, television, false, right? For those of you that didn't at all read any of this, the background story is we're building up an example. In the example, we're trying to figure out why this guy turns into a squirrel, and it's a really stupid example. What we're trying to do is figuring out what events correlate with him changing his status to a squirrel. The way he's showing it, the author's showing it, we're given a different list of, a different array of strings for the different things that are happening, and then we're given the squirrel status. And we're going to figure it all out with an absolutely insane math formula, which I've been complaining about since day one, right? If anyone read this material, you saw it on chapter 4. So foo is a property in my object, and there's two ways you can call it. You can call it like this, or you can call it like this. Those are the two methods you can call the object inside of JavaScript. They practically do the same thing, right? Here's one of the differences. You can say something like this, let key equals foo. You can say my object key, right? But you cannot say my object key. And we call that variable interpolation. So when you're accessing these objects inside of JavaScript, the only difference between these two syntaxes here and here is that the top one inside of the braces is going to do what they call variable interpolation. That means if you give it a variable, it's going to resolve it to a name. Does that make sense? We saw this earlier. Does anyone remember variable interpolation the last time we saw it? We saw it with console log, right? We saw it with quotes and backticks. So we said the difference here, when we looked this up, this was, I think, in the first lesson.
Yeah.
We did this. Foo, right? What is that going to print? Anyone have a guess?
Foo.
It's going to print foo. Now, we also went through this.
Also,
What is that going to print?
Undefined?
foo.
Foo is not defined because we said key. What is this going to print? There you go. That's the example we're using.
Foo.
Foo.
It's going to print foo, right? So in this one, we have this backtick syntax, and we did this in chapter 1. We went through this on a couple of occasions. This backtick syntax enables this $sign and the curly braces. And that's called variable interpolation. It means that it's going to go out and grab the variable and pull its value back there, right?
Right.
So that's the very same thing with the array syntax that we're looking at here. So he's saying that you have this property, myObject.key, and this doesn't do it. Key's always going to just be the word key. And then you have myObject like this with the braces, and it's going to go out and grab the variable key, and it's going to look for that in the object. Okay. Let's take a look at it. Let's go ahead and create a function here, and let's play around with this. Let's say that I have a function, let my function equal, let's do it the other way. People like that, so it's better. Function, my function, key, and then I'm going to create an object. Okay. So let's take a look at this. I have a function here that's defining one of these objects on it, right? And again, these objects are mapping keys to values. We're taking the value, the key foo, and we're mapping it to the value bar. We're taking the value hello, the key hello,
Right.
and we're mapping it to the value goodbye. And then we're returning the result of object key, right? So let's take a look at this. What would happen if we put into here, right, foo? If I call my function with foo, what am I going to get?
Bar.
Going to get bar. If I call my function with hello, what am I going to get?
Goodbye.
Goodbye, right? If I call my function with baz, what's going to happen? Or a different thing?
Undefined.
You're going to get an undefined error, right? Or you're going to get undefined is what you're going to get back, because there is nothing there. So you can't call something, right, and expect to get a value back if there's no key for it set. So if I say my function foo, there's our bar. If I say my function hello, there's our goodbye. And if I say here test, undefined,
What
nothing
about
there.
key in bracket?
Key in brackets like this?
I don't know.
Okay, anyone have an idea what that's going to return?
Undefined.
Undefined. Undefined, right? Because it's simply not there. So we have an object here that is mapping keys to values, and you can access it with two different syntaxes. One of those syntaxes always takes whatever you give it, and it says this is the key. The other syntax says this is an expression, and I'm going to go looking for whatever this evaluates to. You can give it a variable name in that expression, and it looks for what that variable is set to, right? In this case, in our function up here, we're actually looking for the variable key, which is determined by whatever I call that function with. So if I call that function with foo, then key set to foo, this is going to look for object foo. Now let me take the same function that I just defined. Of course, that's going to be fun. Let's take a look at this here. Function, I'm just doing this so I can copy and paste this a little easier.
You have a typo in function.
There we go. Key 2. Just get rid of that key. My object. I'm going to go up here and return object. All right. So we have one difference here.
Use dot notation on the return.
That's right. I use dot notation, right? So what's going to happen here? If I give it foo,
Undefined.
undefined. If I give it bar,
Undefined.
undefined. Does everyone get that?
No.
Okay, let's go through it. If we give it dot notation, it's always going to be looking for this as a string. Now here's the thing. In the object, there is no key. There's only a foo and a hello. You don't have key anywhere. So because you don't have key anywhere, it's just going to keep returning undefined. There's no way to change that, right? Let's take a look at this one more time. We're going to come up here, and what I'm going to do is I'm going to say,
Let's see. There's no key named key before.
okay, now I put a key in there, right? Now there's a key called key and a value called sup. Now what happens if I call this?
Sup. Sup would return.
How do I get sup to not return?
Type something other than key.
Well, there's no way I can call it to change it is what I want to get, right?
Oh, I see.
So there's no way, no matter what I provide to this, right, I'm going to get sup. If I provide to it, as
Oh, I
long as
see.
it's valid syntax,
Oh, it's
always going to return it, right? And the reason is simple, because if I look at that function that I just declared, object.key, this is never changing. It's always saying, get me the value behind key,
right.
right? So you have one method with variable interpolation, it does something interesting. You can give it a different variable. This method, it's always returning the same thing. There's no way you're changing it. Is there anyone hung up on the difference between variable interpolation and no variable interpolation? Okay, it seems pretty simple. That's really all that there is behind those two syntaxes. And all that we have now are arrays and objects. Does anyone have any questions about arrays or objects? Have we all seen these things before? We have some Perl users, some Python users. Anyone a PHP user? Anyone ever use that? That's a great thing to not see hands go up on that.
Related to that, But last time, something I wanted to ask you about. You talked about ways you could generate arrow function. There are 3 ways to generate functions, and you said 2 of them are really good.
Right.
And my question was, the way when you use arrow function, is there anything the arrow function does that can't be accomplished by the other way of creating a function?
There was a minor difference. We said that there was a minor
Oh,
difference.
that's okay. That's just that one. Okay.
I'm happy to answer that question outside,
Okay,
right?
okay.
That's the one thing I'm trying to kind of like dodge some of these
No, that's
more
fine,
complex
that's fine.
answers.
Yeah,
Yeah.
sure, you
Okay.
did say that. Thank you.
Okay. So we have these arrays. These arrays come with different methods. Does anyone remember that I've had this question. I've now presented it twice to you because I think it's one of the most important takeaways from this class. When you want to learn, if you forget what the things a method or an object can do, what is the trick? Does anyone remember it? Slam on tab,
Tab.
right? Slam on tab. That was my trick. That's my gift to you. So if we go down here and we're looking at the console and we have this array, right? Let A equals 1, 2, 3. And you want to know what A can do. What are we going to do?
Slam on tab.
Type it, A dot slam on tab, right? Now you're going
It's okay, we all know you're just freestyling this.
to... I thought, I could have sworn that he goes on this at this section. I think this is actually a different version of the ebook that I'm reading, to be honest with you. Okay, so yeah, he goes into this, the stacks and the objects. Let me make sure that this isn't in the one right before this on this one.
I think if you will search with last, just search with last.
I could have sworn that he goes into this stuff. I just don't see it here in this one. So yeah, you have this notion of stack. The bottom line is very simple. There's a stack and a queue, and these are 2 different methods of doing something, right? If you have a queue, a line, right, then the first thing you push into the array is the first thing you're going to get out of the array, right? So you're prioritizing, and you're taking the things in the order in which you push them on. In a stack, like the array is with push and pop, which he's showing here, then the last thing you push on is going to be what you get back. So push and pop are the 2 terms here. And what we're going to see is how they work. If we say let A equals 1, 2, 3, I can see the array right here. And if I go B push, where's that 5 going to go? At the end. So which side is the end on this?
On the right side.
On the right side, right? So the array, when you're looking at it like that, is going to grow on the right. Now if I look at B, you're going to see 1, 2, 3, and 5. Now why I chose 5 is it's returning 4, right? That's the amount of things that exist after you run the command. That's what push is returning. So if I say B push 6, you're going to get 5, right? Because it's just returning the count. Now if I say here B pop, what's the return from that?
5.
5, correct? So B pop,
No, return
Oh,
six.
6. 6 is the last thing I pushed in,
Yeah.
I'm sorry.
Oh, right.
6 is
Yeah.
the last thing I pushed in. Who said 5, who said 6?
I said 5.
You said 5, you said 6, right?
I said, actually I was thinking of count, so how many will be remaining, so like, because push is giving you the count, how many will be.
Right.
But pop is not giving the count, pop is just removing it.
Pop is giving you the last element that it removes.
Okay.
That's right. So if you say here B equals 1, 2, 3, and 5, let's try this again so everyone gets it. If I call count, what element am I going to get off?
4.
If I call B dot pop, what would I get out?
5.
5. There you go. That's your difference. And it's actually length, I think, is the thing in JavaScript.
Yeah.
Yeah. All right. So so we did pop, and now we're going to go look at the keys, right? So we have this function here that he's going through when he shows this, and it's dot keys. So we have an object, and I told you when you forget about what's on the object and you want to know what you can call, what do you slam?
Tab.
Right? And here's the catch. Everything he's going through now is just, he's showing you one more thing that you can get when you slam on tab. So if I hit tab there, you're going to see all of these different things that I have. He's showing you left and right show up. Left and right, they're both there. And then there's also a method called keys, which is going to return to you, there's not a method called keys, object.keys. There's a method, there's an object out there called object, and if you call object.keys, you can get all of the keys of that object, right? So there's things here in JavaScript, they call these primitives, right? And there's one of them is string and one of them is object. And these provide to you different methods that you can use on your own objects. One of them is called keys. So if you want to see what you can call an object, right? If you slam on tab, you're going to see keys, and you should see values. These are some examples. And he's showing you these are things you can provide your object to get the result back. So if I have this thing, an object, and it has left 1, right 2, and I want to get back 1 and 2, I can call an object.values and provide our object. And we get the array 1 and 2. I can call object.keys and give it our object, and we get back the keys for it, left and right. So these are different things that aren't methods that we can use inside of JavaScript, and he's showing you some of them here. So that's what he's doing here, if we didn't get that. He's saying, and he's declaring himself an object, left and right. He's showing you what happens when you call those properties, left, and then what he's doing is he's showing you here, you can find out what properties an object has. You can use the object.keys function. You give it an object and it returns the array of the object's property's name, right? And he's showing you that inside of this object, you have different functions that you can use. And his example is keys, but there's also the values. Did anyone take it? Does anyone have any questions over this? Did anyone look at this before the class, or? Okay. So we have different, he's going to go through some of this stuff as we're going, and we're going to run through his code and take a look at it. He has here, let object A equals A1, B2, and then he has this, he's calling object.assign. And he's providing it the first object and new variables, right? What he's doing now is he's printing it out, and you're seeing that you have A1, B2, then you're having A1, B3, C4. So this here is providing to you new keys and values for your object, right? Let's take it and let's run this in our own console, right? So when, that is, there we go. We're using the same names every time. Okay. So you declare object 1, A1, B2, and then what you're assigning to this original object is B3 and C4, right? What you're getting back out is A1, B3, and C4. Then you're printing that out, you're getting A1, B3, and C4. What you should see here is this B3. This B3 is different from your original one, right?
Right.
That's what he's trying to show you. When you call object.assign, you're overriding them. Another way to think of object.assign is merge, right? You have two things that are storing keys and values inside of JavaScript. This is your first one, and what you want to do is you want to merge on top of it another object. And JavaScript gives you a method to do that, this object.assign. Again, we've seen now a couple of different things on object, right? We've seen object.keys. What does that do?
Gives you the keys of that object.
And how does it show it to you? It shows it to you in
An array.
in an array. Object.values is the same thing. Now we're seeing the third method, object.assign. He's just going through and he's showing you some examples of different functions on the object, right? And if you want to see what they are, all of them, again, you can just type it out, and hit tab. And you're going to see all of them. Keys, seal, values, assign should be up here at the top, assign. These are all just different things, and he's just showing them to you. Different examples, right? All right, so now what he's got here is he's declaring himself a data object. Now this looks a lot like something you'd see in an actual real-world program, right? He has this thing he's creating here that represents a journal, right? Now for him, a journal is a list of events and whether or not you're a squirrel. That's a kind of goofy example he's showing you. He's trying to show you how these events are stored in JavaScript. This is where like he tries to tie this together to make sense in an actual application. The events, what is this called? Anyone have an idea? What would we call events here? Key, right? And what is this thing here?
An array.
It's an array, and what would we call that array? If this is a key, then the array is
a value.
It's a value, right? Again, squirrel. Squirrel is a key. And then false is the
Value.
Okay, so then we would say this object here, right? From events to here. This is an object that has 2 key values, right? But here's the thing, we're storing a lot of these events. We're storing them all in an array. And the array has 1, 2, 3 different places with any of this stuff yet. If you're going to do JavaScript, you need to understand all of this code that we're doing here. We're creating a function that adds to the array. That's all that we're doing. That function takes 2 things, events and a squirrel status. And it simply creates an object and pushes it on the array. Okay. Does anyone not understand the add entry function or have any questions about it?
What is false?
Okay, good question. So false and true are whether or not the guy is a squirrel. And I know how stupid that is, but if we take a look at it, he has a graphic down here somewhere. This is it. So this is the graphic. So the true and the false are going to create something like this. No squirrel pizza, squirrel, no pizza, no squirrel, no pizza.
Okay.
So if you eat pineapple pizza and it turned into a squirrel.
Pineapple pizza just turns you into a horrible person. That's a whole other conversation.
But when they add those entries, where do they get them? Are they the original ones we had with the first time?
Yeah. So what we're doing here is we're looking at.
Remember them? Where did he?
It's when we add these entries, what they're doing is this function add entry is calling journal.push, which is going to push it onto this journal array. So every time we call add entry, journal is going to get one more thing.
But where are they coming from, those things?
He's giving it to us as examples.
Oh, okay.
Right.
They're not drawn from some cache somewhere or.
No. He's literally, I just copied and pasted this add entry command from the book. This is an example we're running with. So, yeah, okay. Now we're looking here, and essentially what we have is, let's just go through this as an example. So I want everyone to be really clear about this easy stuff because it's about to get really stupid really fast, and this is where me and the author really disagree about how this shit should go down. You have this thing here, add entry, pizza is right here, and then the value of this is false, right? On this one we don't have any pizza, and the value is false. And on this one we don't have any pizza, and the value is true, right? That's the 3 data points that we have from this. In the actual example though, if you go down here and you look at the Eloquent JavaScript stuff, he has the code examples right here. And you can go to number 4, and this is what he's actually generating with on the book. He has this code and he has this journal. So you can see that on the book, he has a lot of different things. This is what he's generating with the book code, right? And if you look at the book code, you can see there's quite a few of them that represent pizza and a state. These are all of the days he ate pizza, right? Okay. It's cute, it's kind of cool, it's also super complex, and it has nothing to do with JavaScript. What he's trying to do is figuring out if he didn't eat pizza, right, he can look at the state of the squirrel, and you can determine whether or not you change state from squirrel to not squirrel or vice versa when you're not eating pizza. The other stuff on here, you're determining whether or not you change state when you did eat pizza. That's the whole program we're creating. That big ugly math formula, which we're not going to go into, is essentially just doing that work for you, right? Now, here's the thing about the big ugly math formula. I said that there's one advantage to it, and that is that often in computer programming, you don't understand what the code you use does. There's a lot of examples about that. It's simply out of your pay grade. This is a great example of code that is going to be out of a lot of people's pay grade. Don't let that scare you off. You're just using it, right? It's going to find out whether or not the events correlate with this data. Does anyone have any questions about that? Yeah.
You said correlation, but isn't it exact? I mean, if a certain things happen, you know that 100% the case the person will be a squirrel. I mean, correlation, I always think correlation is like a 0.5, you know, that maybe it explains, say, 25% of the variance. But this is isn't it going to build something that will tell you, you'll be able to predict 100% what the result is?
No, you'll never get that with correlation. And this is the whole, this is the philosophical position, right?
Okay.
Even if you did have it 100%, even if 100% of the time event A correlates with event B, right? It's not to say that event B is caused by event A. So causation would be, yeah.
So this, so again, you won't be able to, you said it is correlation.
It's truly and strictly philosophically and in computers correlation.
Okay.
And we're using this silly statistics formula to figure out whether or not these events correlate. Okay, I just want to be sure everyone, we're about to break for this thing. I want to be sure everyone understands the concept of the journal being this array of objects of events, that they understand how these events look, that we have inside of them different things that are happening and whether or not you're a squirrel, that we have this journal he's providing right here with a bunch of different events and a squirrel status, that we're going to create functions that process this journal to determine what correlates with your squirreliness. Right? Does that make sense to everyone? And if you haven't read the material, I'm really sad and sorry, not because you should be doing it, but because it's that math formula is horrific, and I just want you to be able to follow the JavaScript of it, right? So don't let the little phi's and the Greek symbols scare you off. Cool. Yes. All right. Pizza. Let's get pizza, and then we'll go back. We'll type this stuff up, and we'll. So the next thing that he looks at here is he says there are two factors with the correlation that are clearly stronger than the others, right? Eating peanuts has a strong positive effect. Look at that guy stand out. Now that we've reduced that big long list of maybe 50 events to just this 10, we can see here we have a 0.595 for this correlation. Now, not a statistician, but I think that means that you have a 50% chance or something like that of
I
this.
think it explains actually about 36% of the variance. You actually have to double it, and it tells you what percentage of the variance you can explain.
There you go. And if you have any questions about math, you have calculus experience too?
Yeah, it's been a while, but yeah.
This guy's your guy to go keep them away from me. I just do the JavaScript stuff. So yeah, we all provide different skills. So yeah, what we're gonna do is we're gonna look at it, and he's right. So we have two factors here we're gonna focus on, right? If we have peanuts and if we have brush teeth. Brush teeth is bad, peanuts is good. If you don't brush your teeth and you eat peanuts, if you don't brush your teeth and you eat peanuts, you're very likely to turn into a squirrel. That's where this is going, right? So what we're going to do now is we're going to look in the event log for only things that include peanuts and that don't include brushing your teeth. And here's one of the cool things here. We talked about includes. Includes is going to return whether or not that element is in the array, right? So when I had k, I said k is equal to 1, 2, 3. K dot includes 2 is equal to true. Now look here, what we're doing. We have this. What is this? Anyone know? Okay, what class of operators is this? We went over this. This was the very first question I asked. Does anyone remember the name of it? It's called a logical operator. Logical operator. Logical operators take Boolean values and they give you Boolean values. You're given here the true, right? And what you want is to invert it. So this guy right here at the beginning, this exclamation point says if I get true, I'm going to return false. If I get false, I'm going to return true. So we're looking here to see whether or not the events includes brush teeth, right? But then we want to say not. So we're looking to make sure that the events does not include brush teeth. That's how that's read. And I just wanted to be really, because I don't know that we saw the inversion thing here yet. Okay, so we're going to take it and we're going to paste it here. This is only going to return the events that satisfy both of those criteria. And what we're going to do is look for the table 4, peanut teeth, and there you go. You get your 1, right? So what we've done here, I'll just be clear about it. We take peanut, so we have a function. We have a function called table 4, right? Let's take it back a step. We have a function called table 4. Table 4 takes 2 variables. What are those 2 variables? Anyone remember? You got it, man. You are the one to go to for questions.
What did he say?
Very high accuracy of getting it right when I call on you. I'll give you a shout out. Takes events. What is the second variable?
Squirreliness.
The log.
The log.
Oh, yeah.
The log, right? It provides you a log, which is the global, right? Now, events is a what?
An array.
Array.
No.
Object.
Key.
It's a key, right?
Key.
What kind of key? It's a string. It's a string. It's not an array. What does to include that?
Wholly if it's inclusive.
In English, we just dropped this, but it's definitely something you need. It's unfortunate we simply don't have words for it in English. If I say something like this, be at my house in between 2 and 3, and you show up at 3 sharp, did you do what I told you or not? Some people say no, some people say yes. That's the difference between inclusive and exclusive. If I say be at my house in between 2 and 3, and you show up at 3, you either screwed up or you did exactly what I wanted, and no one knows, right? And that's precisely because we don't say whether or not the range is inclusive or exclusive. With computer programs, though, we're very explicit about it. Some things even have specific operators to tell you the difference. You'll see it right here. The end index is exclusive. That means if I say to be at my house between 2 to 3, and you get there at 3, you screwed up because the end is exclusive. 3 didn't count. You better be there at 2:59 or 2:59:59. Anyway.
Is there any logic why they would say the start is inclusive and the end is exclusive? Why would, like, pick one? Why did they do both? To me, that's ridiculous. It's counterintuitive.
No, there is a reason. It keeps you from having to add 1 to everything, subtract 1.
I see.
And it gets rid of the 0 index.
Okay.
A lot of that.
I mean, I would have just simply said you have to go with something, but you can explain that if this is what they call the fence error problem, right? So this is a pain in the ass, and just think about it. The fence error thing is something you constantly got to think of. If you say increment start I at 0 and then continue until I is less than 10, right? You know I is never going to reach 10, right? Because less than 10 means exclusive to 10. That's the difference between less than and less than or equal to. Less than or equal to is inclusive of 10. You're accepting the right-hand side of that operator, right? Exclusive means you're not. And when you're talking about an integer incrementing by 1, exclusive means you can't get to it because the condition's no longer true, right? Okay. Anyway, yes, if that's a problem, I don't know. It's pretty much an English thing. It's really not complex, I swear. It just so happens to be we don't have a word for that, and we don't use a word for it, and we get along with our life because if someone's off by a minute or a second or a penny or a dollar, generally speaking, you just tell them and things are golden. When the end of an index is not given, slice will take all of the elements after the start index. That's also kind of cool. If you want to say, I want to throw off all of the crap before element 5, you can slice at 5 and then you drop it, right? You take 5 until the end because slice is inclusive at the start and it just keeps going. We have this function called remove. Remove takes an array and an index, right? And it's essentially slicing the array from 0, inclusive, you're going to get the first element, until the index, right? And then you're not going to get that element. So
It's modifying the array?
Let's take it. Let me show you. We'll take a look at it. So if I say here k equals 1, 2, 3, and I say remove k 1, what is that going to return?
1 and 3.
2 and 3.
It's going to return 1 and 3 because it's
Okay, yeah, yeah.
removing.
It starts at 0.
It's removing from 0 to 1. And it's concatenating the okay, it's concatenating the other half of that. That's what it's doing, right? So because we're removing in the middle, it's removing from 0 to 1, right, which is the first element, right? And then the second element, or whatever. The index value is 1, it's the second element, okay? Because you're starting at 0. So the index value of this, if I say array slice, let's say I have k, and I say k slice 0, 1, right? That's going to return 1. It's not going to return 2, right? And the reason for that is because what we're doing is we're removing things from 0 to 1. From
including only those.
Including
From
only
0 to
those.
1.
Including
It's
only those. I'm sorry.
Exclusive of 1.
That's right. That would have been good thing you caught me on that one. Yes, you're including only those from 0 to 1, right? Now what we have to do is we have to get the other half of that, right? To get the other half of that, we're going to slice the index plus 1. Now remember, if you don't give it a second variable, if you don't give slice a second variable, it keeps going. So if I say k.slice, and then I say, rather than the 1 that I gave it before, I'm going to say 2, right? You're going to get 3. So what I want to do is I want to have the 1 and the 3 together. And now they're introducing to you a new function called concat. And concat adds the two arrays together. So let's look at that, and then we'll come back to this. If I say 1, 2, 3 dot concat 4, 5, 6, what do I get? 1, 2, 3,
Yeah.
4, 5, 6. If I say 1 dot concat 3, like that, what do I get? 1 and 3. This is how I would have built this up. This is not how the book did it. I want you to see that concat is essentially the way you add two arrays together, right? By extending them into each other, right? There's different ways you can add in arrays. Like if I say here, one method is if I wanted an array with one element plus an array of one element to be the sum, right? Like if I wanted 1 and 3, I could get a one element array of 4. That's not what concat is doing. Concat is called concatenation. You'll see this often in computer programming. Concatenation means you're taking all of the elements of one side and you're taking all of the elements of the other side and you're returning an array with all of those elements together, right? You'll see that with strings too. If I say something like this, and this is why we don't say summing. If I say foobar plus baz, right? Like that, you get foobar baz.
Right.
The word here is not sum, even though you're using a plus operator. Let's be clear about that. It's a plus operator, but you don't sum together strings. You concatenate strings, right? For an array, a plus doesn't work. You can't say 1 plus 5 because you get that. And that's because JavaScript is dumb. Some languages are smart about this. So with JavaScript, what you do is you say 1.concat 5, like that. Of course, you do it right, like that. And now you get an array with both of them. That's what this is using. It's saying, give me the slice, which is the range that includes from the start to the index, concatenate it with the range of the index plus 1, the element after the index. That's how you're removing an element.
Yeah.
So if you have something like 1, 2, 3, 4, 5, and you want to remove the third element, you would do it like that. Now what we've done is we've removed 0, 1, 2, 3. We've removed the fourth element. And we did that by adding this range, concatenating this range with this range. Everyone see it? Okay. Moving on. Strings and their properties. We set kim equal to, we set this variable kim equal to the string kim, and we're showing here that you, even though kim is a string, you can add properties to it, but they don't stick. Look, I'm gonna be honest with you, this is trivia. I don't know why this is here. Yes. Okay. If you care, you can definitely take a look at it. You have the ability in JavaScript Kim. You can set a variable to a string, right? You can also set properties on that string, but they don't hold. I don't know why anyone cares. You'll never see anyone do this because it does absolutely nothing, right? Nothing. So he's just showing you it does nothing. That doesn't sound too productive. Other than that, he's showing you here that strings work like arrays in many contexts, and they do. Remember when I said you can take a string like foo and add it to a string, concatenate it to a string like bar, like this, and you get foo bar? What would happen if I did something like this? Yeah, let's do it like this here. I think this actually works. I'm not 100% sure though. Yes, there you go. Okay, so the string foo has a method on it called concat, just like the array does, right? And you can provide to it another argument, the string, bar, and it essentially concatenates it into foo bar, just like the array does. What he's showing you here is in many aspects, the string and the array work pretty close to the same. And he's showing you some of that here. You can slice from a string, you can find the index of on a string. Again, this is not stuff you're going to use too often. This one you will use, .trim. Trim is kind of cool, right? So if I say, and I coming back down here to his example, let Evan equals Evan. Okay, this is a string with a bunch of white space, right? You see all the white space here? Here's some white space on this side of the string, and then there's some more white space right over here.
Okay,
So you have this thing called trim, and it cuts it off on both sides.
all the leading and trailing spaces.
All the leading and trailing spaces. You will use that one. That one's kind of cool.
That is cool.
There's another one here called pad start. This is for padding.
Could you use that with arrays too, or is that only with strings?
That's a really good question. I don't actually know the answer to that.
I bet you could. But I
I
don't
wonder if like,
I would
if
assume
an
you
array
could.
had zeros and you trimmed it, if it would get rid
No,
of it.
you can't.
Got trim- Okay.
No. It's a good question. I didn't know that one until I tried it. Okay,
No,
some
you'd have
languages
to
you can't
you'd
do
have to
that.
do it on the string. You were doing it with.
But he was asking about arrays.
Yeah, but you can have an array of strings
You
that
mean-
had leading and trailing spaces.
Trim isn't a method on array.
Right, trim isn't a method on
Doesn't
array.
matter
Oh,
what the size
oh, I
of the
see.
array.
You'd have to iterate over strings.
Yeah.
All right.
And then
You
have
could do
different
something, you
buffers.
could iterate over them and run trim, it would work fine. Okay. So, split, okay. Split is also kind of cool. You can take a string and you can call this method on it called split, and it essentially takes that string, looks for that character, and then splits that string into an array of strings based on that character. So if I take here this sentence and I split it here on the space, right? Words is now an array that equals each individual word in that sentence, right? So you can split sentences on spaces or characters. We already went through repeat. Remember the tree experiment? I cheated and I showed you guys a really quick way to do it. That's repeat. He's showing it to you now. We are way ahead of him on that one. String.length, everyone's seen that one. We went over that. Strings can also work with indexes. Remember I said they kind of behave like arrays? Some languages do this slightly differently, but this is kind of cool. If you say something like Evan, right? And I want to find something like a letter, we're just going to say Evan 8. And then there's C, because that's the 8th character, the 9th character in the array. Because remember, everything in JavaScript is 0 indexed. So 0 is where you start. Then you count 8 further, 7 further, and you get C. Okay. Boy, that's really stupid. That number is 5, 1. Yeah, essentially there's this method in here where you can deconstruct things with this syntax. This is really not all that important. You can learn about this later. Essentially, you can throw remember how I said JavaScript will call the function only based on the name? It doesn't match the parameters. Okay, recall that? that's a specific attribute of different computer programming languages. Some of them use the parameters to match what function they're going to call. JavaScript doesn't. So JavaScript gives you a method to say, I'll take all of the rest of this crap in this variable, which becomes an array, right? So you can say, I know I'm going to take one variable, and then the user may pass to me 2 or 3 or 4 or 5 other variables. I'm going to take them all in one thing. And in this case, he's got a function called numbers, right? So a function called max. And essentially max doesn't require any variables. But all of the different variables and parameters you give it, it's going to take them into a numbers array. So you can call max on 2 things or 3 things or 5 things or 10 things. And it does this with this ... And in JavaScript, they call that the rest operator. And that just means throw everything else into that, right? Assemble that into an array.
But you can always pass an unlimited number of arguments into a function anyway, right? So max, you could pass it 3, 4, 5.
Until you get a stack overflow, yeah.
Okay.
You can pass as much stuff as you want, but the point here is that you need to have a method of getting that junk. So traditionally, there was something called an arguments object, which you may have seen that, and that was magical. And JavaScript said, we don't like this magical way of doing things. You don't like having this special magic in there. So they created this ... operator. And essentially that says, put everything into numbers, right? And that's called the rest operator, because it literally just means the rest of, right?
So it means create an array?
Create an array and put everything into it, right? Everything else into it. And this is part of something that JavaScript calls deconstruction, which is very popular, and you'll see that later on. And it's useful in other syntaxes. You will very seldom see this. Robert is a professional JavaScript programmer. We both do it for a living. Robert, have you ever seen rest in a JavaScript function?
Rest?
The rest operator, ...
Yes.
Okay. How often do you see this in production code?
Very, very little.
There you go.
I add it everywhere I can, but you know, I'm only one man, so.
That's the point here, guys. What I'm trying to show is that this is like, you don't see that because with TypeScript especially, right? With TypeScript, the whole idea is you want everything to be strongly typed, right? You want everything to be strongly typed because that way you can run a program before you're on production code, and it'll tell you where you have bugs. And this kind of stuff is a great way to break shit. And I'm not saying that it's all bad. I'm just saying it's more bad than not using it. So there's other things we have here. The math object is the next thing we're going to go over. He's saying that, look, he created that function called max, right? But it's already provided. And it's provided on this thing called math, right? Okay, quick question. You want to know all of the shit that math does. What do?
Tab. Google it.
You type math and you slam on tab, right? Math dot slam on tab. You see all this stuff here? You have I think that's hypotenuse for a triangle. No idea, never used it. There's a lot of different things in here you may or may not need. CLZ32, some kind of checksum, maybe, don't know. He's calculating a random point on a circle with more math that we don't care about. Apparently, you can give sine and cosine an angle, and then you can do that way too, and find a random point on a circle. Math.random, you will use this. If you ever need a random number, you can call math.random and you get a random number.
Oh yeah, between 0 and 1.
Between 0 and 1. Yep. Exclusive of 1. Yeah, that's a valid point. Inclusive of 0, exclusive of 1. Because that's fun. And then here's where he goes into destructuring. This is where it's actually useful. This is where you will see it a lot, right? And this is pretty clever. We had this function is the one that we used earlier, right? We said phi table, and then we started indexing into the table in a static fashion, right? So we said that the third element, the 0 element, so on and so forth. This is another way you can do it, right? So in this method, he's giving each one of the variables a specific name right off the bat by giving it the array syntax and telling it what the name is. And that's a relatively new feature for JavaScript, but it's really cool. Look at the difference between the top and the bottom. Clarity here, clarity here. This is a lot easier to follow. You deconstruct it once, the array, and then you can just provide to you the variable names inside of that array. You don't have to keep track of this whole cable and element stuff. Okay. And he's showing you here that you can do it this way too. So you have this object with a key of name and a value of Faraji and an age of 23, right? You can deconstruct that object with this syntax. And this is going to look really weird. And again, you don't have to know this to even be a professional JavaScript programmer. But there's your trick. Curly braces, name. And then you can say console log, and just as if it was a variable. Now let me show you something here. Just to make sure that this isn't overly confusing, because it's really not a very important feature. If I have this, that's exactly what he's got, and I can console log name. Here's the way that you would do it if you didn't know about this trick, right? Let name2 equals, well, let's go back. Let object equals this, right? Now I can say let n1 equals, or here. That's one way I can do this, right? Actually, that's not a way I do that.
That you can do what?
Yeah, that's what I don't want to happen. Yeah, okay, 1 second.
Just remove the let.
Yeah, that would work too.
JavaScript won't let you declare the same variable multiple times in the same scope, so it's throwing error because you already declared the variable name.
That's right. This is the new syntax you're seeing, right? And now name equals Faraji, right? Now this is the old syntax you've been seeing, right? If I could say something like this, let name2 equals object, right? Name. Faraji. I could also do let name3 equals object dot name. Those are 3 different syntaxes that all do the same thing. In the first one, right here, we set the variable name by deconstructing object. It's going to look for this thing, and it's going to create a new variable called name with it. That's a special syntax called deconstructing. I'm only showing it to you because the book has it. You don't have to use this.
The advantage is not repeating name, though.
The advantage is not having to repeat name. There's a name that programmers use for this, by the way. Robert, you want to give a shot?
Don't repeat yourself.
Terse, right? We simply say that this is more terse, right? It's not about, we say that this is a more terse syntax. Now, if you're using a language that encourages terseness, like Perl, you can come up with a lot of really cool and clever things similar to this, right? This is a relatively new thing for JavaScript. This is your older way of doing it, right here, right? With the bracket syntax or the dot syntax, and just setting the variable. And there's nothing wrong with that, and it's far more common even today.
But with the first one, you're constrained to use name as the variable, right? So you couldn't like use it to compare it to the name.
You're not actually constrained. I don't really want to go into the intricacies of that syntax. There's a lot of crazy shit. If you guys really care, by all means look it up. But no, you're not constrained to use name as a syntax. It gets insane. The point is there's a new way of doing things, and he wants to show it. Okay, we have this syntax here. When we printed this stuff out, and we see this, and it's got a key and a value and a key and a value. Here's the thing. This is called JSON. Who here has heard of JSON? Show of hands. Anyone know what it stands for?
JavaScript. It's a binary object.
My man would get this every time.
What did he say?
Say it again.
JavaScript object notation.
That's it. JavaScript object notation.
Oh,
JSON.
man.
That's what it stands for. So here's the deal. The deal is when you print objects out in Node, you type them out, what you're actually seeing is JSON. That's actually JSON. You can create the objects in Node. You just give it the variable name, and it prints them out in JSON. There are 2 functions you can use to do that. JSON stringify and JSON parse, right? JSON parse takes a string of JSON and gets you back the object. JSON stringify takes an object and returns a string. Okay, so we have this guy here, and we're looking at it, right? If I say something like object, this, if I put this in quotes, it's an object. It's a string, right? If I take it here like this, I want to be sure we understand the difference, and I put this in quotes, That is a string. How do I get from that string to an object? This is something you're going to do often, because when you make a request to a web server, you don't get back an object, you get back a string. Between eating pizza and turning into a squirrel, that's our problem, right? Okay, now remember, what I'm focusing on in the class is the JavaScript stuff. So if your head is going, what are you talking about? I'm talking about, we're essentially taking that events thing, right? And we are creating input to a function, right? Table 4 does that. Table 4 iterates through our journal, and it creates this tabulation of whether or not you have the event and whether or not you're turning into a squirrel. That's all Table 4 does. This is what you need to learn. The rest of it is just spectacle. That should not overwhelm you, and I'm afraid it will. That's why I think it's a bad example. So, does anyone not understand this function? Does anyone see that what we're doing here is we have a journal, right? That journal is this massive guy, right? And we are taking it and we're starting I 0. We are ending I at journal.length. That's the last entry in the journal. And we're incrementing I. What we're doing here is we're setting the entry. We're operating off of each different entry as we iterate through that array. We're setting the entry to journal with the index, right? So we're saying, give me the first element of journal, give me the second element of journal, give me the third element of journal. And then we're stating on it for each different element in that journal, for each different thing in that journal, right? Start our index value, which is a stupid named variable, as Jason said, at 0. We're stating that if it includes the event, we need to increment it by 1. And the reason for that is think of it like a quadrant, right? If we go back down here, we're looking at it like a quadrant. Here's the things that have the event, right? If you include the event, pizza, you're moving to the right. This is 0, this is 1. This is 2, this is 3. If you have the event, you're moving to the right. If you have the squirreliness, you're moving down. Why are you moving down? Because 0, 1, 2, 3. You're adding 2 to that index to move down, right? So if you think of this as an array, the bottom 2 elements could be on the right of it. And that's exactly what we're doing. To get to the bottom, we have to add 2. This box here is 0, add 2, we get here, right? If this box here is 0, we add 1, we get here. That's what this guy is doing. That's just the voodoo behind it. That's what we need to understand. We need to understand that we're iterating through this journal array, right, which is our event log. We're doing this and we're returning something. And when we look at what we're returning this. Now this is otherwise useless, this output, right? All that we're needing this output for is because we have another function that does math we don't understand that requires it in that format. That's all you got to do. There's like some people will just say, focus on, I'm just saying, don't focus on the math. Just focus on the JavaScript because that's what we're trying to learn. So we take it and we provide that input just like this. Table 4 is producing this stupid array, and then it's calculating phi with this function phi. And phi does stupid math that we're not going to go into. But that's often what a programmer is, because you get a library that does very complex things, and if you even start to scrape off the onion skin, you have lost all of your productivity for the week. I guarantee you don't want to know how your Windows is drawing on your screen. It's just, you just take that kind of stuff for granted and you move on with your life. Okay. So now the next question is, we know how to calculate it for 1. How do we calculate it for everything? Well, he does that with another function, and it's very simple here, called journal events. So let's take a look at this guy, right? This isn't too complex. We start off with this thing, events, and we give it an empty array, right? Now we have to fill up that array with events. Why are we doing that? Let's take a look at this. We want to calculate this input here, this stupid thing right here, for every different event we have in our log. Let's go back to our log. Remember how all of these are events?
Yeah.
Here's the thing. We want to get all of the events for the whole log. No entry in that log has all of the events. So we have to iterate through all of them, and then we have to find the unique events, and then we have to iterate through those unique events to produce this output for each one.
Well, not unique, or just,
Distinct values.
they're distinct values, I guess. But they're not necessarily unique, they might happen multiple times, that's all.
Right, yes, distinct is probably the more correct word, yes. Correction accepted. There is a semantic difference between unique and distinct. Okay, so, but just so everyone understands, you know, what we're doing. We need to get the distinct events. Some of them are in here twice, like brush teeth. We don't want to have the output twice. But none of them are all in the same event. We have to go through the whole list together. And that's what this function does that they've created. For all possible events, that's right. All possible distinct events. We're going to paste this guy right here. Boom. Oh, we're not going to paste that right there because it's stupid. Okay.
You might want to reload the page.
Did someone just give me an idea?
Because I think I saw you delete part of that text that you were copying from.
This text?
Yeah.
Oh.
So there's let events equals, there's something missing there.
Aha. Good eye. Yes, he's good at that. I accidentally deleted this. That's what happens. You get weird, bizarre things if you. The text is actually. I don't know why. I have no idea why you would make the text in your HTML page editable when you can't run it. I don't. I think that's a recipe for disaster. Okay, so we have this function here, journal events. We call journal events, and we're giving it the journal, right? And then we paste that there, and now we're getting a list of all of the popular events, right? And it's very simple. Iterate through every different entry in the journal, right? Then we're iterating through every different event in the events. Remember, the journal has two keys and values. One of them is events with an array of text. The other one is squirrel. So we get through every event, and then we get through every entry in the journal, every event in the journal's events. And then we say, if it's not in this array up at the top, add it. And how do we do that? We're introduced to a new function now. And that new function is events.includes. But it's actually array.includes, right? So any array has a function in JavaScript called .includes, and it tells you whether or not that array has that element in it, right? Okay, so two questions. If I take it here and I want to say var k equals 1, 2, 3, and I want to know, damn it, var k equals 1, 2, 3, and I want to know whether or not k has a 2 in it, right? What could I use? Includes. What would it look like? K dot includes 2, and you get true, right? Here's another question. Let's say you go home a week from now, you're like, damn it, what was that method to figure out whether or not stuff is in my array? What do? Slam on tab. We're gonna, you guys, I'm telling you, the single biggest skill in being a computer programmer, slam on tab. Okay, K, tab, and you'll find it. It's somewhere in there, right? It's in there. Right there, K dot includes, right? You can go through it, there's your reminder. Okay, learn how to use the documentation. It is your friend. Okay, so now we call this journal events, and it tells me all of these distinct events for the journal. And now what we have to do is we have to create one of those outputs, the table 4, remember? That is also really a pain in the butt.
Does Control R work?
No, surprisingly, but it was a great suggestion. So there's there we go. I don't want to ruin the secret here. Jeez. Okay, there we go. Table 4. So we have this function, table 4, pizza, journal, and it tells me those quadrants, that output that I need for the pizza event. And now I have this list of all of the events. And what I essentially need to do is I need to iterate through all of those events, and I need to put that event name here, right? So I need to iterate through all of the events, and then I need to calculate with them this, right? Each one of the events is going to have a different one. I can do this manually. I could say lettuce, right? Lettuce, Of course, if I typed it right, I could do it. So here's table for pizza, 78941. Here's the quote. Here's the thing for lettuce, right? And I can provide it to this phi function manually, and you'll see I get the result, which is a negative correlation. If you eat lettuce, you're ever so slightly less likely to turn into a squirrel. That's what that's telling you. So eat your lettuce every day. 7% difference or whatever, I guess. I don't even know how to read the phi thing there, but that's what it's telling you. There's negative correlation. So now we're going to iterate through all of those events with this, and here's all we do. For event, in journal of event, right? Console log the event name, and then the result, phi, and then the input to phi, which we generate with table 4, right? So the same way here we generated the table for pizza, we're going to generate the table for every event and calculate the phi value and output the event. This is going to give us a big list of all of the possible events and whether or not they correlate. And this is where you're supposed to go, oh, wow, that's so cool. You know, we did that all ourselves. Okay. So now the question is, how do we clean this up, right? We have a bunch of numbers here and we need to clean it up. What the author says to do is he says he's going to take it and we're going to look for correlations that are greater than 0.1. Remember, lettuce was negative 0.07. That's a very low correlation between lettuce and not turning into a squirrel. We need to find things that are high correlation. He just picks one arbitrarily. You can pick whatever you want. So we're going to take this, copy it, paste it, and now we're going to find just the ones that have a high correlation, and there you go. So now we look at it, and there's his example.
Brush your teeth.
Brushing your teeth is not good if you don't want to be a squirrel. A string. A string is one thing, right? A string is one thing. That's it. So here's the catch. You've got a function that's going to generate you the input to this phi function, but it only takes one event. So how do you get around it? When you have two events you want to test, right? You want to test whether or not you have peanuts and you don't have brushed teeth. What the author's doing here with this is he's creating a new event for the things that satisfy this. He's saying if you have peanuts and you don't brush your teeth, create a new event called peanut teeth. Create a new event called peanut teeth. And he's testing for peanut teeth. And the reason why he's creating a new event called peanut teeth is because his function, table 4, just so happens to only take one string. That's the logic behind it. Now, if you worked in programming, what's another way you could do this? Table 4 could accept an
array or an object.
Could accept an array or an object. Because if it accepts an array or an object, you can have more than one thing. And if you can have more than one thing, you don't have to create new events to show combined things. Because then you could just write something like this. You know, event entry includes peanut and not teeth. You know, have an array. If it includes all of the things you have, all the things you don't have, you're done. You just provide that to table and you're done. Table 4 and you're done. Table 4 is stupid. It just accepts a string. So we have to go through and add the appropriate string for the case we want to look for. And then we're testing for it. Okay. I know that was a little mind-bending, but does everyone get what's happening and why we're doing it? Okay, and after we do it, we get 1, which means we solved the problem. This dude is turning into a squirrel for God knows what reason, but it has to do with him eating peanuts and not brushing his teeth. And we figured it out by using this phi function, which we created but didn't understand. And think of that, if you're a programmer, that's going to be you copying shit from a library or Wikipedia, throwing it into your program, having it work, and then we essentially iterated over his event log, provided it a list of all of the distinct events, created all of these phi values, and then we started narrowing it down. We said greater than 0.1, and then we had a smaller list, and we said, there's 2 things, let's examine that. And we examined it, and it worked. And we lived happily ever after. All right.
Dumb question. All of the manipulation with the objects and things like that, referring to all these pieces, is it just a bunch of practice? I'm trying to, this was hard for me to, when I see a problem like this to wrap around, boy, how do I describe that and start coding it? It's pretty difficult for me to do.
So there's 2 different methodologies in programming, and if you're a programmer, you've heard both of these. One of them is bottom up, the other one is top down. So top down is what engineers do, right? that means they tend to sit back and they tend to think about the problem and they say, what is the best way to go about solving it? And they usually come out with a solution that's better than layman, right? The layman guy, you know, he gets into the car and he says, something's rattling, let me just hit it with a hammer, and then you break something, you say, okay, now it's broke, I gotta fix it. You just start tackling the obstacles as they come up, right? Now the question is that all of this complexity here, I'm more of a bottom-up guy myself. I don't mind saying it because bottom-up guys get shit done. I can do the top-down thing, but in the real-world situation, what happens is you're given a list of all of this crap, this event log. The number one problem you have to do is how am I going to represent it as an object? That's it. Now you may not represent it in the most optimal fashion, right? The first time around, you may decide to in version 2 change the way you're doing it. Number 1, get it into the program, JavaScript, right? Number 2, figure out how you're going to operate on it. He did it in the same way I would do it on that. Right now, I don't like the way he represented those objects. I would never have started off from that, but it's very simple. He's trying to show you that, and then he's creating something that processes it, this table 4, and then he's creating something that accepts that output, phi, right? Essentially, that methodology is, that's very close to a real workflow. And I don't know what else to say. You would never represent this crap like that journal, but everything else he did is pretty close to how you'd actually do it. It's not far off at all.
Well, the journal would just be in a database somewhere, right?
Most likely, yeah, because he's only got 90 events, but you know, seldom do you hit that sweet spot with computer programming where you're only at 90 events. Normally you're at an obscene number of events, like millions or billions or something crazy like that, in which case you throw it into a database, or you're not in that level of scale and you know, you just have 5 or 10 or 20 or something like that. But yeah, so if it's saying like this, you can do it all in JavaScript. You don't need a database, and that method works fine, as we've seen. You know, if you have you know, millions of events, I don't know if you want to do them this way. But you try it, and if it doesn't work, you fail, and then you implement it in a database. You know, it's still, the bottom-up approach will work. Just, you know, keep bashing at the nail with a hammer of some sort. All right. Any other questions? That's a good one, by the way. You're just going to have to learn it. You know, find out what approach works best for you. Anyone else have any questions about data structures, looping over them, the program that we've created? Anything but the math. Okay. Let's take a look, because there's a couple remaining things on here, and it's 8:11, and then we'll be done within 20 minutes, right? And maybe even quicker than that. Further Arrayology. So here he's showing you, okay, here he's showing you that, remember, pop and push work on the top, right? Some languages don't have this. JavaScript does. It has unshift and shift. These work on the bottom, right? He's got index of is an example of one thing. You can give it something like a number, index of, and it will return to you the index. Remember, computer programs they tend to be zero index, right? There's some exceptions, but most computer programs, you're safe to assume that if you see an array, it's zero index. This is the zero element. This is the first element. When you say index of 2, it's going to find 2 and return to you the index of it, which is 1. And if you call this array with an index of 1, you're going to get 2. These are inverse functions. I will say this, I almost never use this. In fact, I don't think I ever use this. So this is neat to know, but you probably won't be using this all that much. Okay, you have this one down here, 1, 2, 3, 2, 1, and he's saying last index of 2. It does the same thing, except it starts on the other end of the array, looking for the 2. Slice, this is relatively cool. This is a method of mutating the array, right? So you have an array 0, 1, 2, 3, 4, and you're slicing it 2 to 4. 0, 1, 2, you start here, and then you're going 3, 4, but you don't include that, it's exclusive. And then that's what it's saying right here. The end is exclusive. So exclusive, you guys know the difference between exclusive and inclusive?
Yeah.
Okay, really quick on this one, because this is important if you don't know it. If it's inclusive, that means that whatever operation you're doing, it includes that last element. If it's exclusive, that means it doesn't. If I say you need something in the range of, let's say, let's say 1 and 2 o'clock, we'll use time. If something happens exactly at 2 o'clock, do you day? There's another key, which is squirrel, and it stores a value that is either true or false, right? True meaning the guy is a squirrel when the events happen. False meaning the guy is not a squirrel when the event happened. This is the stupid example that we're given. And we're trying to figure out what events correlate with the guy becoming a squirrel. So essentially, we have 4 options here, right? We have he's not a squirrel and he ate pizza, because that's the event we're focusing on in this example. We have he is a squirrel and he ate pizza. We have he's not a squirrel and he did not eat pizza. And we have he's not a squirrel he did eat pizza, right? I think I did that right. Anyway, true, false on all sides. Okay. So we have these functions we're going to be using, and he created them. And in it, there's this big, intimidating thing called phi. And I told you all, don't let it scare you off. So now we're going to look at it. And here's what we're doing. Essentially, we're taking it, this table. We're going to copy this code he gave us. And I'm going to paste that right here. There we go. And I have my journal up here just to show you that my journal is working. And it has all of that stuff in it. And if I type in journal.length, I can see the length is, what is 90. There are 90 elements, 90 events, 90 entries into our log.
Look at this one.
Yeah, but it's on my left shoulder, and that's weird. So like I said, if you want to know what you can do with journal, type journal, and then just slam on tab, and you're going to get a whole list of things. You'll see there's our length. And that's one of the things I want us all to learn is this tab slamming nonsense. Okay, so.
Would you ever call them elements in an array? You ever call the array elements elements?
That's a great name. That's a great thing to call it. Yeah. Yeah. So you have 90 elements in that journal array where each one of those elements is an object with 2 key value pairs. One representing the events, one representing the squirreliness. Okay. And now what we're going to do is we're going to look at this thing called phi. And I said that we are, let's give it that. And let's go back here to this code that he has. So what he's doing is he's saying that, let's go up a little bit. We have these 4 different values that we've got, and we can represent them in an array of 4 things, right?
So out of those things, sum to 90, I take it. There's some to the length of that thing.
Well, let's see. Let's use JavaScript to do it. We should be able to take it and go. For, we can say here, let sum equal 0, and then I can go for let I equal 0. I is less than k dot length. I plus plus, and then I'm just going to do sum plus equals ki. There's your answer, 90. So yes.
Oh, I see. So basically taking each one of those cases
and we're breaking it down, right? So we have 90 elements in the array, and then this is the count of how many of them represent no squirrel, no pizza, no squirrel pizza, so on and so forth. And if we look here left, right, no squirrel, no pizza, and then no squirrel pizza, and then squirrel, no pizza, and squirrel pizza, right? So we're going boom, 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 right? Just like quadrants on a Cartesian grid. That's how we're representing it. So the question is now, how do we get that, right? So we've created this function, table for, and table for is pretty clever. Let's take a look at this table for function. Table for is going to take an event name, right? And that event name could be something like pizza, could be whatever you want. We saw that whole list of events, right?
Right.
Here's our list of events right here, right? Your event name could be brushed teeth. It could be cauliflower. It could be work. Those are all events. So we're taking an event name and we're giving it a journal, which is that array of event objects. Everyone get that? And then with it, what we're going to do is start out with a table of 0, 0, 0, 0. Now this is also, in my opinion, really, really stupid to give beginners this. I want to go through what he's doing, right? Because I looked at this at Taco Cabana and I was like, well, that's really dumb. He's saying, let I equals 0, I is less than journal length I plus plus. He's essentially going to iterate over this whole entire array. Now here's the kicker here though. This is what I thought was really cute and stupid. Okay. He's saying if the entry includes the event, add to the index 1. And then he's saying if the entry has squirrel, right, if that's true, right, then he's saying add 2. Now, does anyone know what this is doing? That's exactly right. Okay. We have an array. It has 4 elements, right?
Okay.
What we're doing is, if we have a squirrel, we're jumping 2 over. Why are we doing that? We're doing that because in that original grid he had, which this phi calculation is based off of, if you have squirrel, right, you're on the bottom. If you don't have squirrel, you're on the top. And if you have the event, you're on the right. And if you don't have event, you're on the left.
Yes.
Right?
Yeah.
So that's what he's doing. He's using that index manipulation trick to decide which one of those boxes to go into. There's nothing necessarily wrong with that method. It's just complex because what you have to do is think you have quadrants. And you have to know that if you add 2, you're moving from the top to the bottom. And if you add 1, you're moving from the left to the right. And that's essentially what it means. The event, if it's there, it's on the right. And if it's a squirrel, you're on the bottom.
Is index a special variable, or is it just a poorly named one again?
It's a poorly named one. Yeah, so he is actually declaring it right here.
Yeah, index
equals
is just
0.
what we're making up for this.
You could call it something else, like R index or whatever you want. It's not necessarily a bad name for that, because the reality is that this is just a stupid way to store this information, right? I mean, like you could think of a lot of different ways to store this information, whether or not you're a squirrel and whether or not you have the event. How I would do it personally is I would store them both in an object that said, you know, is squirrel true or false, has event true or false, and I'd return that. He's storing them all based on these indexes using this. There's advantages to his way though, because when he does this calculation for this phi thing, which I told you we will certainly not be going into, that's all based on this. So I remember, I told you this is stupid math, and stupid math we don't cover, but the name of stupid math is to get this Greek phi thing, which is going to determine the correlation factor between the two things, right? So that's the important takeaway. And how we're doing that is based on that grid. So if you look here, the grid, this is what determines it. And if I remember right, it's something like, yeah, it's this times this.
So he's going to have a grid for all of the different events.
Wow.
That's the end goal.
Right, okay, yeah.
The end goal is to automate the creation of a grid for all of the different events and to find out what event has the highest correlation to turning into a squirrel. I think it's a very complex beginner's example when you're trying to teach what an array is. It's a horrible example, but it's kind of neat, right? So the reason why this grid thing is important is because you take this and times it by this, and then you subtract it by this times this, and then you take all of that on the top over the square root of the product of all of that crap. I have no idea why it works. It doesn't matter. The point is that the math behind it is based on cross multiplication, essentially.
Matrix math.
Matrix math, right? So yeah, there's definitely a math interest group somewhere that would teach you this better than me. But So we produce it with this guy, and now what we're going to do is we have this table 4 where we give it an event and a journal, and it is essentially going to give us back that thing. So let's say table 4, and let's say pizza, and let's give it journal, and then there we go. That's what we want. Now we're producing the input values to the phi function, right? So this is the grid, 79, 9, 4, 1, just like we saw on the graphic on the website. We're producing it down here by saying table 4, pizza, and journal. I'm sorry, we're going to go over here and give these guys some love. Table 4, pizza, and journal, right? We produce this array, and now we're going to provide it to this function that's going to do deep voodoo that we don't understand, but it takes it in that format, and it's going to produce to us a number. And that number will be between 0 and 1, if I remember right. Maybe -1 and 1, I think, actually.
Oh, yeah. It could be.
That's right. -1 and 1, right? And it's gonna, that essentially tells us whether or not these things positively or negatively correlate with each other. So, let's take a look at it. He does...
By the way, a positive number means you're more likely to turn into a squirrel?
Yeah. A positive number means you are more likely to turn into a squirrel, right? So a negative number would be like, I guess, if you commit suicide, you're definitely not turning into a squirrel. There'd be a negative correlation.
Yeah, like one would be every single time you had pizza, you were a squirrel.
Right. So we're going to take it and we're going to say this, remember the stupid math function is phi, because that's the Greek letter. So phi, table 4, journal, like that, and we get 0.06, right? That means there's almost no correlation, but something has to take it and make it an object. Use this thing called JSON parse, right? So I can say JSON parse this, and
You could write proper JSON first.
The single
Yeah.
quotes.
is that what? The console log. Where did I make the mistake, Robert?
You never turned it to JSON. You just wrapped.
Oh shit. Okay.
I didn't actually know JSON parse was that strict, but
Yeah, I didn't know. I wasn't thinking about it.
too.
Yeah. So
The actual specification for JSON is extremely strict. You have to quote everything. You have to use comments in the right place. You can't have a trailing comment. JavaScript will take things that look very much like JSON, but in a much more easygoing way. For example, the notation where it does name : and it treats it as a string, JavaScript is perfectly happy with that. Real JSON, no, you have to quote it.
That's right. So if everyone didn't catch it, I want to show you. When I printed this, I said object, and I said this is JSON. I was actually lying to you. What I was actually showing you is JavaScript notation, or what you would use is JavaScript to create that object. If you type in JSON stringify and you give it the object, you see this thing here that's JSON. Now what's the difference between this guy and this guy at the top? Does anyone notice? The quotes, that's it. So that's what I screwed up on. So you want to see my mistake? There it is. I copied this and I said that's JSON because it looks like the bottom one, but it's actually not. The one at the top lacks the double quotes. So if I add the double quotes, right, I can actually provide it to JSON parse and I get my object back. He's showing you that there are two features. One of them called JSON parse, which takes a string and gives you back an object, and one of them called JSON stringify, which takes that object or the array or whatever you've got and it gives you back your JSON string. And that's a great way to like write something out to a file. You know, you want to create a JSON file. Remember this whole journal thing that we got? Let's journal. Let's take it. We'll copy it. We'll paste it. Okay, you have this journal right here, right? Now this is, I told you, step number 1 in your project is get it into JavaScript, right? What do you do from it at this point? You want to put it in a file. You want, if you're going to put it in a file, one great method of putting this in a file is JSON. You can store it as JSON. So you would say JSON stringify, and then you would say journal. And you get your JSON object. That's it right there, right?
That's cool.
Now if I want to get that object back from JSON, because that's JSON right there, right?
Parse it.
You just JSON parse it. JSON parse. And you get back your object. So they're inverse functions. That's what they look like together. JSON stringify produces the input for JSON parse, right? And that would have been the same example there but of course we're creating new ones. Why not? Okay, the summary, there are exercises in there. We are already out of time because it's 8:40 and we're over 9. If you guys want to do the exercises, do them and bring them back next Wednesday and I'll take a look at them. And we'll go over some of them in class. I'll probably pick one of them.
I have a couple of questions.
Take some
One
questions.
is, should we be doing TypeScript? Do you write in TypeScript normally or typically not?
I do. I love TypeScript. Should we be doing it? No, because this is a beginning or introductory to JavaScript class. I think it is actually in the book at the end.
All right, a professional JavaScript guy, is he writing TypeScript today? Is that best practices?
It's,
I'm not.
yeah.
I mean, just generally speaking, people aren't. I mean, you certainly will find people who are, but it tends to be, I would guess, something like 10 to 15%.
Okay.
And that's a pretty wild guess, but I think that's what your likely is.
Did you say you do or not?
I'm not.
Okay.
My assumption is substantially higher. For node programmers, I'd say right now it's probably closer to 50 or 60%.
Okay.
If you're writing a node, it's real big.
All right, one other thing. You mentioned things in here that you like certain things about this Eloquent thing and certain things you don't. I went looking online for like maybe another tutorial or whatever, and one of the things that's easy to find is old JavaScript tutorials that just talk about var, 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 var. And the only way that I know right now is if it's a relatively new tutorial is if they're not talking about var, they're talking about let. What else could we be looking out for to avoid being taught obsolete best practices?
I don't have an answer for that. The reality is that JavaScript was a totally stagnant language until probably 5 years ago. And when I say totally stagnant, I mean like woefully, oh my God, you haven't changed in 15 years, blame Microsoft not doing anything. If you find that old code, there is no way as a novice you're going to know that that's old crappy code. Hopefully it didn't change all that much and you're okay. I don't know. The one thing I will say about this book is while I don't agree with the order in which they're presenting the material or the complexity, it's at least relatively new code.
But the one thing you tell us about is there's some esoteric stuff in there. It's like, look, I've been doing this a while. You're never going to see this or whatever. And that's good information. Huh?
Yeah, that's good. Yeah, hard to know. Yeah, how to.
I would blow your mind if I told you about all of the bad design decisions in JavaScript. You could literally buy books on it. There's so many bad decisions inside of JavaScript. There's actually a book for JavaScript called JavaScript: The Good Parts, and it tells you what to do in JavaScript, and I think even what not to do, which may be right up your alley.
Yeah.
And it's probably the biggest selling book for JavaScript, and that just because there's so much bad shit in there that you don't want to use.
If I may, to answer that question, me personally, I would ask people that have more experience, whether that's like this Learn JavaScript subreddit or just the HLUG group, or just somebody who's doing it all the time. You know, hey, what are some good things that I can learn? What's good and what's not?
Right.
I would do it that way.
There's also, we have our own IRC channel. You can drop by and ask me in IRC. I'm there quite frequently. There's Reddit resources you can tap into. There's Stack Overflow, and there's even code-review.stack exchange too. You can post questions on there. Tap into all of those those community resources. Okay. Anyone have any other questions about this material? If not, we're going to recess, and then we're done for the day, and I'll take questions.
Another thing,
Yeah.
the code that you can edit on there, you actually can run that. Just a little drop down, and it's the hamburger menu run code. Mystery meat, but it's there.
There we go. I write very advanced websites,
that's
but I
true.
assume that everyone that I use is dumb. So yeah, it turns out that's very cool to know. Yeah. Okay. Any other questions or things you want to point out? Comments? Okay. Cool. We're done.
Thank you.
Oh, by the way, drinking. In the event that you are a drinker or you want to go socialize and not talk about Eloquent JavaScript or talk about Eloquent JavaScript, we